Hi, everyone, and thank you for joining us today. My name is Becca Refford, and I'm the Marketing and Events Coordinator here at Chariot Solutions. So for those of you who don't know us, Chariot Solutions is a consulting firm that specializes in software development, systems integration, data engineering, mobile development, and also training. We typically use smaller teams of higher level consultants to deliver more scalable solutions for businesses. So if we can help your business or if you want to learn more about us, give us a visit at chariotsolutions.com. All right, so now for the webinar. I'm joined today by my friend and colleague, Michael Hewlett. Michael is a senior iOS consultant here at Chariot, and he comes to you with many, many, many years of iOS development under his belt. He recently upgraded the Journal My Health app from iOS 15 to iOS 16, and that's the case study through which he's going to guide his talk today. He's going to share some challenges, some gotchas, some solutions, and also strategies for ways that you and your team can better navigate these upgrades in the future. So without further ado, I turn it over to you, Michael.
Yeah, thanks. Like Becca said, hey, I'm Michael. I'm a senior iOS consultant here. If you don't know what that means, basically I build and hack iPhone apps. For the past year, I've been working on an app called Journal My Health. Um, there we go. And Journal My Health, as the name implies, is a medical journaling app. We're very creative here when we name things. Um, you can keep track of information like your blood pressure, how much sleep you got, how you're feeling, and all that, so that you and your doctor can notice trends in your health over time and hopefully use that information to design treatment plans. We often work with hospitals and universities to do like medical studies across your logs and things like that. And so, as Becca said, recently over this summer, we moved to drop support for iOS 15. So in our app, we support the current version of iOS -1. Yeah, this is the year that 15 goes since 17 came out, and now we support iOS 16 as our minimum version. Now, technically, we ended up shipping was iOS 16.4 as the minimum support. There were 16.4 actually had it was a surprisingly large minor update as far as useful APIs go. We ended up going with that as opposed to 16.0. But it helped us quite a bit, and I'll get more into that in a minute. And so hopefully you can take some lessons away from how you might navigate similar upgrades with your apps, especially 15 to 16, because this was somewhat of a big upgrade. And I understand even from my friends in larger companies around the industry had some trouble doing this one in particular too. So anyway, about halfway through the beta cycle, I started out by downloading the latest Xcode 15 beta and opened up our project to see what work there was to do. Okay, so seems like it might be a bit. These warnings group into three main categories. There are the just the quick fix, easy miscellaneous ones. They probably have like a button that you can click and it'll fix it for you. I'll go over those briefly on their own just to be aware of them. But the two really big ones that we had to go through were a large migration to Swift Concurrency, away from traditional like dispatch queue, like closure-based asynchronous callbacks, as well as Apple deprecated NavigationView, which is ubiquitous throughout nearly every app in the App Store. If you saw if you saw like a UIKit navigation controller, but in a Swift UI app before, that was definitely NavigationView. They're everywhere. And so Apple deprecating that was a really big deal. It took some work to move over. A few other random things here and there, as well as some new features to take advantage of. But today I'm going to start with the warnings and how they got fixed, and then move on to some of the additional wins. So the first big one, the first warning that we addressed, same one that always comes up in whenever you open a project, a new version of Xcode, just all the like update to recommended settings. There were two in this one. First one was to turn on asset catalog symbol generation for Swift. This is really, really useful because previously you would, so in your asset catalog, you have all these images, colors, data, most things that you need for your app that are not executable. And to reference them, you would traditionally use just raw string literals, which I'm sure we're all aware are very fragile. The compiler doesn't check those. So it's really easy to make a typo and not realize it. And then you've shipped something, or hopefully you haven't shipped something that an image is just missing. But it can take a minute to track down, even if you do catch it immediately. So historically speaking, a lot of us were doing this ourselves. I certainly was. So that's just not something we have to do anymore. The compiler will generate all of these constants corresponding to the names in our resource bundles, and we can just use them inline in SwiftUI, kind of like this. So that background accent references the accent color from the asset catalog, and the image has that initializer for external link. One minor note about this, they don't have an initializer for image that takes an image resource as a decorative image, which if you worry about accessibility, which all of us have to, we have to abide by the Americans with Disabilities Act. Disabled people have the right to a good accessibility experience in software as of the Supreme Court decision in 2019. So we have to care about that. Unfortunately, there isn't an image decorative to market as like this isn't significant for accessibility purposes. So that's the one place I've seen that fall down, but it's really, really useful otherwise. I've started using this quite a bit and I like it a lot. The other build setting that's new it sandboxes user like build phase scripts. So a really common way that apps got hacked up until now were supply chain vulnerabilities. Essentially, rather than your app itself getting compromised, either a framework we use get compromised, especially what this mitigates is if you download a malicious version of a framework, and lots of frameworks on their own already require like a run script build phase. Like Firebase does this, for example. If you use their analytics in order for them to be able to parse your crash reports, you have to upload your debugging symbols that the compiler generates whenever you compile your app and ship it, so that when Firebase gets a crash report on your behalf, it can map a bunch of memory addresses to locations in code that we understand. And so that requires a run script build phase to grab that and upload it to Firebase's servers. But imagine if we had don't have access to Google for some reason. Say I'm traveling in China behind the Great Firewall, and I end up getting tricked into downloading a malicious version of Firebase. It's not actually Firebase, and it takes over my entire machine. This mitigates that. So your run script build phases will run in a sandbox where you have to declare exactly what they have access to, and they will not have access to anything else beyond that. So those were the new build settings that got that were added. There were a couple deprecations that had some quick fixes to them. First of all, locale.region code got moved to locale.region.identifier. In fact, iOS 16 introduced a rich set of APIs around locales, including new like locale.language as a structure, as well as components. It allows you to compose together really hyper-specific locales, like US, but I speak Danish, and I want my temperatures in Fahrenheit, but I want my distances in miles. That's really, really specific and honestly pretty weird, but those kinds of people exist. I mean, I personally am an American. I'm trilingual, English, Swedish, and Spanish. And so I switch between those frequently, and all the measurements that go with that, and all the ways you format numbers. And so it's definitely very useful for handling polyglots like myself. Um, uh, the other one that we had in Journal My Health that we had to adapt to is so obviously we like I mentioned before, we read sleep data. So you can record how much sleep you got the night before and observe trends for like, oh, I feel better on days I get more sleep, or I feel better on days I get less. And so the health kit category for it used to just be a binary, you're awake or asleep, but asleep got split into many different things in iOS 16. It now distinguishes between in bed and asleep. So you can be awake and in bed. I certainly do that a lot. So there are now as well a sleep core, which is like light or intermediary. You just fell asleep recently, you might just be taking a nap. Deep sleep is okay, you're definitely going for a full cycle, you're not quite dreaming yet, but you're sleeping pretty well at this point. Then there's REM, which is the deepest level of sleep. You are fully dreaming, having a pleasant night, hopefully. And so then the old style asleep is now asleep unspecified, in which yeah, it's you're asleep, don't know much beyond that. So if you want a visualization for this, here's this. I noticed that this graph is actually laid out pretty weird, because core is the lightest form of sleep, but it's below REM, the deepest, and deep is not actually the deepest level, but it is the bottom of this. But we all understand how Apple documentation can be weird. But this does show some of the gotchas. For example, like you can be in bed and not awake. One of the bugs that came up as a result of this over the summer that I had noticed is since we were tracking sleep based on being fully asleep, it wouldn't all you only get asleep now if you like wear your watch to bed, and it can observe that you are definitely like your heart rate is slowed down, your breathing slowed down, you are actually asleep. If you don't wear your watch to bed, the most data you're ever going to get is in bed, so we had to add support for being in bed. So anyway, that covers the really light stuff to start out. That still leaves us with 49 more warnings. We got 5 of them. That's definitely some progress. And it wasn't too hard yet. Now, the rest of the warnings are super similar. They group into one of those 2 main categories. And so the first one we're going to look at, first warning we're going to look at looks something like this one. So if you don't recognize this immediately, first of all, I envy you. But what this means, though, is that it's time that we talk about Swift concurrency. So Swift concurrency was a rich set of features of the language introduced with Swift 5.5. Swift now aims to make it so that data races and corruptions from concurrency issues are just a thing of the past. They can be checked and verified by the compiler at compile time, so that it should theoretically be impossible to, if you use everything properly, to ship a data race in production. It's has similar goals to Rust. Really revolutionary. If you've been developing iOS for a long time, this is a really, really common form of bug. And this is a really big deal for Journal My Health in particular, because so I've been working on it for about a year now. And in the first half of the year before WWDC, most of my time was spent tracing down issues that ultimately boiled down to being concurrency problems. And so debugging concurrency problems is a really big time sink. They're not easy to notice or reproduce or identify. So the compiler checking them for me instead takes a lot of mental pressure off my brain, which is amazing. So there were 3 levels to it. It became mandatory in Xcode 15 to choose one. Swift 5.5, which concurrency came out with, has been around for a little bit now. But as of when Swift 6 comes out, sometime in the nebulous future, they haven't exactly put the committee hasn't put a firm release date on it. In fact, they've been working towards it for several years now. But when Swift 6 comes out, these will all eventually be compiler errors. So the minimal level, it will enforce sendable constraints where sendable has been adopted, which it has been through lots of the standard library with concurrency like tasks, and Swift UI has markings for it with like View API, like binding state, stuff like that. A targeted tries to strike a nice balance between minimal and complete, in which it will perform actor isolation checking for code that has explicitly adopted concurrency, but it will, without the like opt-in declare support for it, it won't touch it. Complete will enforce sendable actor isolation everywhere throughout the entire module, even from third-party libraries you import. You can, like, at pre-concurrency import modules that haven't supported it yet. For us, though, considering how many warnings there are to start, and I'm only one person working on this, I decided for now we're going to stick with minimal, which is the default. I still think this is, even though it might not be fully pedantically correct quite yet, some of our modules aren't there yet either. Like I said, it's just me. I don't want to throw the baby out with bathwater and rethink every little decision we've ever made for this app, start to finish, myself right now while I'm trying to get new features built and shipped. But minimal support will provide us good coverage for now. Hopefully eliminate most of the places where I had been running into concurrency problems throughout the year. Have one good shot at that. And it'll give me, my colleagues, time for us to design a better solution to migrate over time to get to complete support, which we're working on. So let's see where we stand on this right now. When our app was built, Swift Concurrency was brand new. In fact, I think the first commit on this app was a little bit before Swift 5.5 shipped. So where there is concurrency, which in the modern world is most places, it's difficult to avoid it at all. In fact, I would say it's impossible to avoid it at all in iOS development nowadays. So of course, it's everywhere. We had done the closure-based concurrency up until now. As I've been working on the app, as I had been working on the app for some of the last year, I've been starting to write some async functions that were like, rather than going back and changing things, adding new things, doing that async. I use task that's marked to run on the main actor instead of dispatch queue.main.async. But I hadn't really started migrating over anything like serious that we had already built yet. So that takes us back to the warning. So basically what this warning is telling us is that bindings are not thread safe. They're a reference type. They don't do any kind of internal locking or anything. And so we can't pass them across thread boundaries. You really should only be using view code, like using bindings inside like literal Swift UI views. But this warning is telling us we pass them across threads and we're not allowed to do that. So let's take a look at the function this comes from. Essentially, we pass it as a parameter. The way that this is used in the view from the view itself, we have the running piece of state, which just marks like there's work happening right now. We start like a progress view based off of this. So the user can see that like things are happening and just wait for them to complete and turn it off when it's done. It's a signal to them that they can restart with work. So we pass that binding itself into a function outside of the view, and that function turns on the progress view when it starts, and then does some asynchronous work, and then dispatches back to the main actor when it's done and turns it off. Now, the problem here is that, so that process asynchronously method inside, that closure could run on any thread. It could automatically be on the main thread. It could be on some worker queue internally. We don't really know. So we have to wrap it in we have to dispatch back to the main thread ourselves. And like I said, I've been doing this by doing it with a Swift unstructured concurrency task and marking it as being on the main actor. That opts us into things like sendable support and these warnings. That's actually a benefit of it. And so we get this warning that we've passed a non-sendable type. By the way, and I'm sorry, I have ADHD, so sometimes I forget where I am. If I haven't mentioned, sendable means that this thing can be passed across a thread boundary. So things that are automatic value types like structs and enums are automatically sendable because they're copied whenever they're written. You never have to worry about mutation. But reference types like classes can implement their own internal lockings and declare sendable support, but that's kind of rare. Binding doesn't do it. And so since it's getting passed across a task boundary, we get the warning. So first big lesson to take away from this is don't pass UI types around outside UI code. Things like binding should live within the view. Swift UI view, one of the key insights when I was learning Swift UI to start, it was really popular to like try to shoehorn in MVVM as an architecture into Swift UI. And over time, you start to realize it actually isn't as great of a fit as you think, because Swift UI views are actually view models. And it's just that you don't have access to the view layer in Swift UI. Sort of like how those like bespoke architectures in the UIKit world always use UI view controller as the view layer rather than UI view directly. Just let view controller worry about that and consider it the view. So generally, UI types like state and binding, any of those property wrappers that you would use, don't pass those outside the view. You should do the work to manipulate them inside the view. So this is kind of fundamentally an architecture issue. The best way to solve this for now is what we ended up doing. That function no longer takes, the function was causing an issue, no longer takes a binding. Binding gets managed entirely internally within the view. And I made that function be async await so that it doesn't have to externally touch tasks or anything like that. It just can do all of its work in line. And we get notified. It just reads like synchronous code at the view layer. All that task gets managed inside the Swift UI view. Now, the cleanest way to do this, because I said before, process asynchronously has that completion closure. Apple understands that migration takes time. It's not going to happen all at once. So while we should be migrating to async await, there's going to be some kind of interim there where we need to shoehorn old closure style API into async await API. And so check continuations are a bridge to do that. Essentially, we get this closure, takes a parameter that is the continuation. And so whenever we want to have have the task move on to signal that our async work is done, we just call continuation.resume. You can also use a result or throw an error with it. Really handy for adapting old API into new code. So that way, when we use this at the view layer, it'll look something like this. Now, most of our work are dispatched through buttons and things like that. And so you can create, when the user presses a button, you can create a task and hold on to a reference to that. And so a convention that I've adopted through this is to, rather than having the Boolean variable running and just relying on me and my teammates to remember to keep that in sync with reality, the philosophy of Swift UI is to derive your view from your data. So a task is effectively just data that represents work in progress. So we only need to hang on to the task while there's work being done, and the existence of a task, not nil, implies that we are running, and we can do things like run progress spinners off of that. And so here I have over time learned to do some extra bookkeeping every time to always make sure it nils itself out again when the task completes. If the task cancels, it doesn't really need to do that because that implies it got dismissed. If you are, if any of this, if you have any scenario where it happens in like an on appear in your app, for example, now you can move that to the task modifier, and it will do basically all this stuff that I just showed you before in one little line, which is really handy. Has automatic cancellation when the view disappears, and you don't have to worry about it. But we mostly dispatch from buttons, so this is what a lot of our views look like now. However, I did end up running into some problems with this at runtime. When we see this in the log, this first issue happens when you use the continuation, you call with check continuation or with check throwing continuation, and then just never continue. It detects that as a leak. The continuation gets deallocated, and it just never continues. Your app hangs. We had that happen a few times. Additionally, you could also, due to race conditions or intent, you could end up calling your continuation more than once. But the API contract is that they need to be called exactly once. And unfortunately, our use of closure-based concurrency, we didn't do that. I didn't get all that far before I ran into several of these issues and realized it was kind of designed that way when it was built. Our app was, at least. And so I realized then that this isn't going to be a small task. Unfortunately, we really are going to have to do this. So I thought about it, and I decided that, like, so we are going to have to go all in to fix all these warnings. I could try to go through and untangle all the web of closure-based concurrency, but that is famously very, very, very hard to do. I really think I'm going to save time overall if I just go for it, go all in to convert to Swift concurrency and make this the compiler's problem and not mine. But in doing so, I know this is going to be kind of a big deal because like concurrency spreads like glitter. Like it's real pretty and nice to work with, but it gets everywhere and there's really nothing you can do about it. Now, I would argue Swift's the fact that Swift gives you compiler errors is actually a good thing, because in languages like JavaScript or TypeScript, the creep issue for this is equally prevalent if you start converting async await over there. But it is arguably harder to deal with because you don't get the same compiler guarantees. You just suddenly get a promise back at runtime and have your code crash or have something different than you're expecting happen. And those are hard to diagnose, even harder to diagnose. And you don't really get very good feedback until it's running in the wild. And rather than the compiler finding it, it's usually user finding it. So ultimately, this is a thing that was going to have to happen no matter what. We just didn't follow the rules of traditional concurrency before. And so we needed to start to fall in line. But Swift is going to support us through the way, make sure we don't mess anything up too badly. By the end of this, we should have a solution that works well for everyone, as long as we bring as much as we can into things that have been like convention before, things like how you're only supposed to call completion handlers once, bring that into the domain of the compiler to check. And then since we're having the opportunity to anyway fix any bugs we found along the way while trying to maintain as much of a one-to-one translation as we possibly can. But key thing for this is you really should be separating your concerns so everything doesn't depend on everything else. Because for example, when you save a journal entry in our app, that calls one function, which then dispatches to lots of other different functions that work like this through tons of different domains. If the various dependencies stayed isolated rather than just being referenced like singletons everywhere, then this might not have been as difficult to just to like have to do everything and untangle it myself. Maybe this could have been localized to a few different modules, but unfortunately that wasn't the case for us here. But the good news is that now our functions are going to look like this, rather than the old way before where you end up like 7 layers down a pyramid of death. You get your asynchronous code reads like synchronous code. It's much easier to think about and reason about. It's much easier to maintain over time. New features and bug fixes will be easier to build because I don't have to spend as much mental work parsing the spaghetti that inevitably ends up from callback concurrency. Old way, it's new ways markedly better than the old way, because looking at the old way, some of the issues here, one of the ways this was functions like this were super common. So usually when you have a concurrent task like a network operation, you can either succeed or fail. You either get data back or an error. And so the way that had been bridged from Objective-C from forever is you get a closure that as a callback will either be given data or nil, or an error or nil. And now theoretically, it should only ever get data when something succeeds and then the error should be nil, or it should only ever get an error when something fails and data should be nil. But really, there's 4 cases there. A lot of these were written like this before, where you just initialize your return data at the start, set it to nil, initialize an error at the start, set it to nil. And by the time you get to the end, you just pass data or error. It's really easy to end up with some kind of construct where you set both of them, set neither of them, and then you have to go handle that case. So in the happy path, you have data, no error, or no data, yes, error. But this is actually a four case scenario, 4-state scenario where there are the 2 happy paths, but you do also have to handle what happens if you get both, or what happens when you get neither. And like, why, like, it usually doesn't make sense to have both. Or neither. Me as a programmer sitting there consuming this API, especially if I haven't worked on the source code of the original function before, I don't really know what to do there. But I have to do something. Not doing something is not a choice. I mean, like, it's just ignoring it, but that's still a problem. So what am I really supposed to do? Yeah, Swift did historically have result, but we hadn't used a ton of those. Result, of course, being where it's like either success or failure. But we don't even need that anymore because Swift has error handling built in now. One of my favorite opportunities we had in converting from closure-based concurrency to using the modern language features is that we get to use Swift's error handling. So the intent of every line of this is very clear. If something happens that's not supposed to be the case, we throw an error, and that's a scope exiting operation. We don't have to, there's not the opportunity to forget to call the completion handler. It'll always just throw back an error. There's not the opportunity to forget to call the completion handler with the data. You have to return something, and the compiler will look at that. You can guarantee that there are only errors on the error paths, and there's only valid data on the valid data paths, and there's no other paths. That cuts the cyclomatic complexity of what you have to think about in half, which is a big win for maintainability and just day-to-day developer happiness. And so at the call site, it now looks something like this. Or I should say, this one bit here won't compile because now we have to be very intentional about about which functions can produce errors. And then the language requires us to handle those errors. So now we know very well when we are at both the defining the function and at its call site, where asynchronicity happens, where the program might suspend, and also where the program might fail. And then we are required to do something about those failure cases. So we can never just like silently just fall over. That's where a lot of crashes come from. And of course, we could also try question mark or try exclamation point. Like, don't try exclamation point. It's a crash. But it is an option if it's there. But so after converting all of our old style closure that can produce an error or not, we can handle it or not, to standard Swift error, Swift concurrency. In the 10 weeks since we've launched the update that supports this, unlike the Boeing Corporation, we've had 0 crashes. Now, I sort of feel nervous about bragging about that, honestly, because like that's one of those stats that it almost makes you wonder if it's not that things aren't crashing, it's that your telemetry's bad. But no, I've really looked into this. We haven't crashed. I haven't gotten a crash report from the wild at all yet since November 1st. And that's like completely bonkers. But because Swift can verify so much up front because I asked the compiler to, it makes it possible. So moving on from there, the way that our another major improvement we can improved on was so, for example, in our app, we cache weather data. So like you can just determine it feels better, like I feel worse when it's humid outside. We have an external service that we talk to in order to get that weather data. And in doing so, previously, we kind of did this weird thing where like we would iterate over each one synchronously, but asynchronously through like recursion through these completion handlers. This is another thing where it was difficult to follow, but it also really slowed us down. Swift Concurrency has a great solution for us here too, in the form of task groups. And so in a task group, we can just iterate over the collection of days we want to look at one by one and create a new task to go get that data. And they all run simultaneously, or the kernel will figure out what should run when. And it will only, the task group will only complete once all the data is downloaded or has failed. So we get to keep using the natural features of Swift. Additionally, it supports cancellation. So let's say the user realized they wanted to make a quick edit to their journal entry that they forgot about. They can stop it real quick. None of the data gets saved. They can make the edit and restart the process, and we don't waste any of their resources. Super easy to do with task groups. Works kind of like code you see on the screen. Now, this resulted in a 30 times increase in performance in saving a journal entry. Another massive, massive performance win. You could sit there, if you were on a slow network before and saved a journal entry, you could sit there for like up to a minute or two just waiting for your data to download. But now it just all breezes right by, no matter what phone you're on, no matter what network you're on. So from there, next major feature we adopted from Swift Concurrency. Less so in this transition. This was greatly when I was building the feature afterwards, but this is going to be a lead into something in just a moment. Swift has the new now concept of actors. They're a utility object, effectively like a class. The difference is that they guarantee the integrity of the data inside it by maintaining exclusive access to that data. So this is where races would come from historically, many of them. If you have one shared instance of a class and then 2 threads doing things, operating on that class at the same time, they can kind of step on each other's toes and end up in an undefined state. Actors make that impossible. Operations upon it are generally asynchronous as a result, because you have to account for the fact that it could be in use right now or blocked. But with Swift actors, the compiler guarantees proper call site usage. And so you can eliminate lots of data races by using actors rather than classes if you ever have to pass them across threading boundaries. Now, the lead into the thing I was talking about, it's time we talk about core data. So core data sits at the core, sits at the core of most of what we do in Journal My Health. Been around since the 80s. It was developed at Next Step. It was one of the original Objective-C frameworks. And it is built around an object called NS-managed object context. Now, if you think about it, NS-managed object context is a utility object. It's a special case of a class, subclass of NS object, etc. It maintains the integrity of the data that it manages via exclusive access. Operations upon it are generally asynchronous. But the thing about it is you have to always make sure that you are operating on data that it manages inside a call to perform or perform and wait. That's just convention. The compile, like, you have to remember to do it. But the gist of it is that NS managed object context is itself an actor. It's just a washed up one from the 80s that no one really wants to be around anymore. But this last bit, the thing with you have to make sure you're always calling perform yourself, is kind of important, because we didn't do that very much before. So we were semi-regularly just passing managed objects that were meant for view code over into the background so they could be read into a PDF or modified by network data. That was another major source of our threading woes. So perhaps the biggest part of this concurrency migration for our app was I converted everything so that rather than passing around NS managed objects, we pass around object IDs as much as possible. So then if you go down into some other concurrency domain, you can just load it from an existing object on that context and do your work and perform and be done with it. Any other, so it's core data was built in mind with the idea that, like, these objects would eventually be read from view code. And when it does, it's going to be unwieldy at best to be inside of perform all the time. So managed object contexts can be bound to the main thread. That's one of the two concurrency types that it does. And the objects that it produces are then safe to read and write on the main thread. Swift Concurrency, new Swift Concurrency, can help us out here. Because before, we would, you just had to remember yourself and be aware when you were crossing threading boundaries, which is, again, not always very clear. If you mark something as being at main actor, then Swift will make sure that you can only ever reference it from the main actor, the UIQ. And so then the integrity of those objects is then verified by the compiler, another thing the compiler can worry about for us that we don't have to. You should do this very liberally. Annotate everything that makes sense to use with main act, to everything that needs to be on the UI thread. You should go out of your way to mark it as at main actor. You can put it on just about anything, including types like structs and classes, or properties, local variables and stuff, global functions. If it needs to run on the main actor, you should mark it as at main actor so the compiler can always verify for you that that API contract is always being fulfilled. Also, another gotcha on this. Uh, Generally, if you have a published property on an observable object, you should either mark the entire observable object itself as main actor or at least that published property, because it is still a violation of the Swift UI, like main thread only view API contract, to update a published property from a background thread. You'll get a little warning. So yeah, use this very liberally. But anyway, that's what it took for us to upgrade to the minimal support of Swift concurrency in our app. This was a big undertaking, but there are now no more race conditions. We are at 69 files changed, 4,466 insertions, and 3,651 deletions. My bartender just took delivery of his new Maserati. My spark for life is now 5% less bright, and it only cost one soul of the innocent. But we no longer have race conditions. We haven't crashed in weeks. We're looking really bug free at this point. And that feels really good. We also got the opportunity to adopt some new async only APIs. Like this is one of the reasons we went with 16.4 instead of 16.0. Web authentication session. You can now get that from the environment. And rather than having to maintain a whole bunch of complex URL parsing logic to talk to Fitbit, or whatever other external service, web authentication session just handles that itself internally, and you get an async await callback from it. HK statistics query and sample query descriptor brings async await to HealthKit, makes it much easier to reason about. And likewise, NS managed object context also does get a little bit of help from Swift concurrency here, since perform has an async await version of it that can also return data. So if you are loading data off of a managed object, you don't have to make another like nested structure to dispatch onto the main queue. You can just return from your call to perform and then get it back and work with it however you want on whatever queue you were on before. Really handy. Great. Okay. So cyclomatic complexity is way down, much easier on my brain. The compiler worries about way more of our problems that had been plaguing us for months. Doing real good. So let's see how many more warnings there are to fix. Cool, we fixed 2 so far. Now, those 2 were 2 very, very big ones. Most from here, it's a lot easier. They are one of these 2, and they're significantly more straightforward to solve. So the first one, this has to do with the fact that NavigationView was deprecated in iOS 16. Apple is moving to a new system. They call it Navigation Stack. It's rather like a family of navigation components, because NavigationView was doing so many things at once. But the way we dealt with navigation links changes quite a bit. In this first one with manual navigation, previously you would have like a data type that like enumerates all the screens you can go to from this view. And it'd be hashable. You pass that as the tag to a navigation link. And then you would maintain a binding for like is active, you would maintain a binding for the currently selected screen. And when that selection is equal to the tag it's given, it displays its content, which in this first one would be that text subroute. Now with the new navigation stack flow, you just need to pass that one value, the hashable bit, and NavigationView or navigation stack manages the selection externally, and you have more control. Getting to that in a moment. I'm getting ahead of myself. So manual navigation is a pretty quick change, but we rely on programmatic navigation quite a bit in this app. And NavigationView historically made it super clunky, because you would have the destination for a navigation link should go to, and then you would have that is active binding for like yes or no, this is being shown. And navigation link really wants to display itself on screen and make it available to be tapped to the user. It is a view after all, but we just want to do programmatic navigation, trigger this from like our own custom button or something. So that means in order to not have it display, you have to render this weird empty view thing, which is kind of awkward. Empty view is mostly supposed to be like a placeholder, but we're using it as an actual view here. So it didn't really work very well. And especially because like these is active bits, you had to be like inside each individual step of the view and have you would have this complex web of views that depend on other views being behind it and before and after it and all that. It got really unwieldy. And there was no place to read where you were in the current stack. And so, yeah, it got gross. But now in iOS 16 Swift UI, you have in navigation stack, which manages its current path externally. So rather than you not having any access to this, now you can continue to not have access to it if you want, and navigation stack will still do it for yourself and use pure manual navigation if you would like. But now you can maintain your own separate state variable that represents the current contents of the stack and manage that directly and pass it around however you want. So the type of data is a collection of path elements, and each element in your collection, each position in your collection represents the data that's necessary to render that step of the navigation stack. And you can control what's just being displayed on the stack simply by just manipulating this array. The thing is, so navigation destination 4 down at the bottom there is what defines what is going to be displayed for what bit of data. So we have our own enum path that we've defined somewhere. And so when navigation stack is looking at a path, it will render some subview, which then takes an instance of that path and will know what to do with it. Now, if you want a heterogeneous data or heterogeneous collection of data, Swift UI does have navigation stack. Or sorry, navigation path is actually what it's called. And you can put anything, take anything into it as you want, integer, string, custom data types, have fun. I tried to stick to the custom enum method with an array because it brings more into the domain of the compiler. The compiler can give us better information about what's there, what we've handled, what we haven't handled. Gets easier to manage because it's Swift's problem and not mine. So in order to do this, I did build a little extra infrastructure around it. It relies greatly on this protocol Navigable. Every enum that defines the paths that the stack can go to should conform to Navigable. Hashable is a requirement just of navigation stack, but a key insight here is that I made this conform to view. So that way you can define your own enum, reuse it however you want, wherever you want, with whatever stack you want, and it will always produce the same data given the same view given the same data in a somewhat more reusable way. And then your navigation destination, when you take in one of these path enums that conforms to navigable, you can just put it right there and let it be up to the enum. It moves the concern over to the path itself, keeps your files shorter, nice things like that. And then additionally, I defined a navigator class, which is generic over one of these navigable conforming types, so that all it does is it conforms to observable object. We still support iOS 16, not 17 as the minimum, so we don't have all the fancy macros and all that yet. So we still have to do observable object and published. But it is made for subclassing. So if you have, like in our login flow, for example, there are lots of different ways you can get into login, lots of different paths you can take. And so I just subclassed navigator and made login navigator so that it has it knows what flow it needs to follow and can manage all that itself. But what's extra great about this is you can pass it down through the it's a reference type, so it can be modified from anywhere, and you can pass it down through the environment really easily. And so way down in the tree, way away from where navigation stack was defined, we can just declare that we want this environment object that is the current context navigator, and we can go up and down however we want just by manipulating its path. Really, you should be using the environment as much as you possibly can to pass around your dependencies. It's Swift UI's built-in dependency injection mechanism. It's a lot nicer of an experience than using singletons everywhere. Use it liberally. And now we're at the point where there are no more warnings. We have gone through all of the mandatory upgrades. There are a couple additional wins from here that I'm going to touch on real quick, but this was the bulk of the work. And we're at the end now. So to mention the new things real quick, there were some new scroll view APIs that surface really well. First of all, you can now interactively dismiss the keyboard, or the user can interactively dismiss the keyboard. So like when they scroll up, it doesn't matter, but when they start scrolling down, then the keyboard will start dismissing. But if they scroll back up, it'll come back up. That used to be very hard to build on your own, but now Swift UI just does it. I think one of the biggest things I was excited about is the scroll bounce behavior based on size. Accessibility concern, there should be a scroll view at the root of every view hierarchy, because if the user turns dynamic type up or down, then or on a tiny device, the view could grow so that it gets cut off. And if that happens, you need to scroll. But before, if you put the scroll view at the root of the hierarchy, then it would always, like, you could always drag up and down even if everything fit. And it just kind of felt weird. It provided a bad user experience. And so I had previously been doing this like weird workaround with like geometry reader and passing things up through preference keys to try to determine the content size, but got to delete all of that code and just do scroll bounce behavior based on size. Now, if the content fits in the scroll view won't scroll at all, but if it overflows, you get the scrolling. There's also new time primitives in iOS 16, clock duration and instant. They're highly flexible and highly accurate, and far more type safe than just simple time intervals and dates, because you can specify like duration.seconds or duration.minutes, etc. Swift native API for interacting with time through async await. You can suspend the process, wait certain amounts of time. One of the biggest things is that duration has the Swift UI style like dot formatted as a full-scale replacement for date components formatter. And I've been doing a lot of extra work in the app before to try to cache date components formatter and generate the right things based on versions, and it was weird. All that gets to go away just in favor of like duration.seconds1.formatted. The really big lesson here is to let Apple do the engineering and maintenance for you as much as they possibly can. The right amount of code is none. So if somebody else is willing to write it for you, you should be doing that, and it will serve you very well in the long term for maintainability, especially in little one-person shops like this. But got to remove a ton of dead code as a result. Like hundreds of lines are gone. So now the app is much smaller and easier to think about, which has led to huge maintenance time savings since then. In fact, a colleague of mine, Zach, had worked on this app for a year before I had joined. We didn't have a ton of overlap, but he recently started working on it with me right after I had merged all of our upgrades. And Zach's a really cool guy. He also has ADHD like I do. We both just jump in and focus on things. So we don't always like necessarily give a ton of feedback. But one of the things I was proud of is when he started reading it, having known what the app had looked like before, I got a message from him one day that he said he really likes how I've cleaned it up. And so I think that really speaks to just how much of a complexity savings it can be, such that even going through so much evolution, someone who lacks context on the project can understand it very quickly and finds it easy to read and easy to parse. So yeah, those were all the benefits of getting through Swift concurrency and all the upgrades that have come recently. So before we part, the last bit of advice I have is to, when the summer beta season comes around, you should be testing early. You should be testing often so that realistically, this should be part of your development process. So that when the operating system, when the updates actually get shipped, you aren't surprised. You have a good experience ready. But additionally, you are participating in the beta cycle over time. And you can submit feedback early. You can affect how the finished version of what gets shipped to everybody looks and feels. And then yeah, just be creative about how you can take advantage of new API changes, because there's every year there's some huge new feature, like new focus modes or like notification options and stuff like that. But the smaller stuff like little additions to scroll view and clock APIs and stuff can make really big impacts as well. So yeah, that was our experience. I don't know how the little title of this to ask for questions got deleted, but yeah, if you have any questions, feel free to ask.